Hello, this is Information Service Engineering, lecture number 3, Linked Data Engineering. In this part of the lecture, we are going to talk about the RDF Turtle Serialization. And let us start. So you remember in the previous part of the lecture, we discussed about what RDF is and how to represent facts in RDF. And also we said that RDF comes with several different serialization formats. Some of them are the N-triples, the RDF XML, the JSON, the Turtle, the 3G, the N-quads, and the RDFA. So in the course of these lectures, we are going to focus into the RDF Turtle format. So that's why we are going to emphasize on it and give more details. But before going to that, let's see some other formats first. So let's have a look to the N-triples format or notations, how it's also called. So here you see that in the top of our slide there are two triples in a graph representation about Pluto. It's our running example. So what do we see here is that we have our subject, which is Pluto, and is linked to a date through the property discovered, and is also linked to another entity through the property discoverer. This entity is Clad Tobo, which is the discoverer of Pluto. And let us now see how this part of the graphs, how these two triples will be formatted according to the N-triples notation. So, the first characteristic of the N-triple notation is that the URIs or the IRIs are always into angle brackets. And you can see it here in the gray box that we have. So, this is the same information as we have in the graph, but in the N-triple notation. And you see that all the URIs are in the angle brackets. Also, we see that the literals are included into quotation marks. And in the end, what else we have here is that every triple ends with a period. Okay, so let us see another format now. This format is called JSON LD. So again, we have the same example as a graph, and in the gray box we have the example as the JSON LD notation. And let us visit it. So, first we have the subjects. Here the main difference is that the subjects are into quotation marks and not to angle brackets are in the previous one. And then we have the predicates. Again, the predicates are into quotation marks. And in the end, we have also our objects where they are in quotation marks, regardless if it's a literal or an object. You see that first we have a literal, since before it there is the identifier saying that it's a value. And in the second object, this is an ID, meaning that it's a URI. Nevertheless, both are into quotation marks. And let us move now to the RDF Turtle notation, in which we are going to focus. So again, the same example, and you see here in the red box, this is the RDF Turtle notation of the example. Does it look familiar? Probably yes, because the RDF Turtle notation is the extension of the JSON format. But here, the RDF Turtle notation looks a bit shorter, since here it allows for abbreviations for better readability. And let's see what this actually means. So into the N-triple format, the RDF Turtle notation is the extension of the N-triples format. So here we see first how the triples would look like in the N-triples format, and then in the yellow box how they would look like in the RDF Turtle notation. You see it's way shorter, and let's see why. So first, here in the RDF Turtle notation we have prefix directives. So those, they let us associate prefix labels with a URI. So you see the prefix here DBO is linked to a part of a URI, and whenever we want to use this URI again in our triples, we don't have to repeat the whole URI, but it's sufficient if we just say DBO column and then the name of the property. So this makes our triples to look a bit shorter. Then we also have the base directive, which provides a URI to complement all the relative URIs. So you see here that we have the at base and then part of the URI following it. And whenever we have to use this URI, we can just put the part of the entity into angle brackets without repeating again this part of the URI. But the RDF Turtle notation can be even shorter. and that is by using semicolon instead of the period in the end of the triple. Semicolon here indicates that the subsequent triples have the same subject, and this is also called the predicate list. So in case we have two triples where they share the same subject, we don't have to repeat the subject again. It's sufficient if we put a semicolon there to separate the two triples. And we can make it even shorter by using comma instead of period or semicolon here. So the comma indicates that the subsequent triples have the same subject and property this time. So this is also called the object list. In case so we have triples that they share subject and property, we don't separate by period, but we separate by comma, and then we put only the object values where there is a difference there. And let us move to the typed literals in RDF Turtle notation. So here we have our entity Pluto, which is linked to 4 literal values through 4 properties. And if you see here in the RDF Turtle notation format, after a literal there are these 2 hats and then the type of each literal. So what do we see here is that 2 of those, the first 2, they are actually double values. Then it comes a date, and then in the end we have this symbol at and en. This specifies the language that the literal comes from. In this case, it's English. And let's see how RDF Turtle handles multi-value relations. So what do we know up to now? We know that Pluto was visited once by a spaceship called New Horizons somewhere in 2015. Okay, so far so good. But what if we have a second visit in the future in Pluto? How are we going to represent this information? So one could say, okay, perfect, we assign 2 more properties to the entity Pluto, another one which is called a space mission, and another one visited to represent this new visit to Pluto. Yeah, but the thing here is that we don't have unique association anymore, since then it is mixed the information. We don't know which date is associated to which spaceship. And to solve this problem, RDF Turtle uses blank notes. So do you remember the blank notes from the previous session? So the blank notes can be introduced to introduce resources that they don't need to have a name, but in this case can be introduced to represent multi-valued relationships. So what do? We introduce 2 blank nodes and separate the different space missions. So this information cannot be mixed anymore. And let's see how these blank nodes are represented in the turtle notation. So here we see how we represent an anonymous blank node, which is a subject in this case. So we have these brackets, which there is nothing in there, and this indicates an empty anonymous blank node being a subject. But here we have the anonymous blank nodes to be both subjects for some triples and objects for some other triples. So to represent that in the RDF Turtle notation, we do it in the following way, which is also called nested anonymous blank nodes, since all the information is included into the brackets. But those blank nodes actually can have a name, they can have an identifier. We said in the previous lecture that they cannot be dereferentiable from another graph, and this is still true. But nevertheless, if we assign to them an identifier, they can be dereferentiable from the same graph or the same document. So if we do that, we can split the previous triples instead of having them in a nested format to have them in this way. So we can introduce these 2 identifiers and then split the triples where each of these 2 triples, they have their own subject. And it's another way to represent the same information, but might be better readable. And let us see some more RDF structures that we have here in this format. The first is called the RDF container, and then we have also the RDF collections. So those are 2 data structures to enumerate any resources or literals. The first one, the RDF containers, is an open list, means that we can continuously add new elements into it, while the other one is a closed list, the RDF collections. We are not going to emphasize to those since they don't add new semantics here, they are just called semantic sugar, but in case you're more interested, you can find more information in the literature about those. And then it comes also the RDF reification, which we can use, which is nothing more than an abstraction for making a statement about some RDF triples. And this is particularly useful in the case we want to model the provenance of the data. For example, what we can do with a reification is to say that DPpedia states that Pluto has been discovered in 1930, and this we do it through the RDF reification. So, in the next part of the lecture, we are going to talk about model building with RDFS.